Since December 2021, the James Webb Space Telescope has been unlocking various secrets of our universe. From providing newer images of galaxies taken by the Hubble Space Telescope to enlightening experts on supernova remnants and peering into the early universe, the spacecraft has already discovered so much. In the latest observation, the powerful Webb telescope has just captured a new deep field view of the universe, offering a look into some of the farthest reaches of space. In Webb's image, hundreds of objects are visible, like galaxies among the black ether of the cosmos, each teeming with stars and planets. Many of these galaxies are spirals resembling our Milky Way galaxy. The deepest ones appear red as the expanding universe stretches their light into longer wavelengths of red light. But that's not all. This view, which looks back at galaxies billions of years ago because it takes that long for such old light to reach us, reveals several ancient galaxies and the black holes at their centers merging just a couple 100 million years after the Big Bang created the universe. Join us as we dig deep into this new Webb telescope photo that truly boggles your mind at the start of everything. The cosmos grew at a truly terrifying rate at the beginning, expanding exponentially. Space begot space, and reality was stripped of all form by space's expansion, becoming a tenuous, near-featureless void. If you could have sat on an atom, though there were no atoms, not yet, and gazed out at the rapidly expanding universe, you would have seen nothing, only a freezing, suffocating darkness. The remorseless stretching of space would have carried all other objects far out of sight faster than the speed of light. Beyond an unreachable horizon, paradoxically, as space expanded, the world visible to any would-be observer shrank to a tiny, inescapable nutshell, binding every speck within its own isolated sphere of nothingness, separated from all other such specks by an ever-growing void. This age of extreme expansion has been given a rather mundane name: inflation. How long inflation went on, we do not know. It could have been a mere instant or an eternity. In all probability, we will never know, nor are we likely to discover what, if anything, came before it took hold of the cosmos. Any traces of earlier epochs have been erased by the growth of space. But we do know that, at some point, inflation ended. And as it ended, the universe roared into being. As the force that drove inflation dwindled, its power birthed innumerable particles, filling the gasping void with a searing subatomic fire, the primordial plasma from which all objects in the cosmos would later form. From darkness, light within a trillionth of a second, the forces of nature came into existence, and with them the first and greatest blaze of light in cosmic history. Though inflation had ended, space was still expanding, albeit at a less ferocious rate. As the cosmos continued to grow, the primordial fire began to cool. Elementary particles, the building blocks of everything yet to come, fused to form the hearts of the first atoms. Over the next few minutes, the nuclei of the first chemical elements were forged: hydrogen, helium, and lithium. For around 380,000 years, the infant universe was filled with an incandescent fire, cooling slowly as space continued to swell. Then, at a critical moment, the temperature dropped low enough to allow electrons to wrap themselves tightly around wandering atomic nuclei, forming the first whole atoms. At this moment, the primordial flame went out, and darkness fell throughout the cosmos. A long dark age began. For hundreds of millions of years, the universe was filled by a warm hydrogen fog. But in the darkness, the first seeds of structure were gathering, slowly at first, then faster and faster. Hydrogen and helium were drawn under gravity into ever thicker clouds. As these clouds grew dense, they also grew hot. At last, somewhere in the unsearchable reaches of space, the pressure at the center of one cloud became so intense that it ignited a nuclear fire, the spark of the first star. Light flooded back into the universe, and the dark age ended with a cosmic dawn. Soon, the universe was filled with stars, bright points of light in the slowly expanding dark, gathered in the first galaxies. They forged chemical elements never seen before: carbon, oxygen, nitrogen, iron, and many more were scattered through space. As these first stars died in blazing supernovas, from their glowing embers, new generations of stars were born, and yet more elements were forged, a continuous cycle of birth, death, and rebirth. around 9 billion years after the cosmic dawn, in an outer spiral arm of one of the hundreds of billions of galaxies now spread through space, a new star flickered into light. About it circled a fleet of worlds, and on one rocky sphere in Earth matter somehow came to life. Under the guidance of dumb physical forces, atoms arranged themselves into ever more complex organisms that grew, multiplied, and evolved. For billions of years, the pale blue orb teemed with living things. Species emerged and perished, and the dance of evolution went on until, at last, humankind stood on the surface of the Earth, gazed up at the stars and wondered. This story of the cosmos, its origins, and its history has been gradually pieced together over centuries by the collective effort of thousands of people. The fact that modern science allows us to speak with such confidence about events so remote in time and space that they defy imagination is surely one of the greatest achievements of our species, particularly when you consider that this story was assembled by peering and prodding at the universe from a rather restricted viewpoint on the surface of an insignificant little rock hurtling through space. But while we know how the universe began, the data we have amassed in both particle physics and astronomy tells us that we still only know about a tiny fraction of the universe. Looking at the sky, we observe that on the largest scales, matter is organized into galaxies and clusters of galaxies. Galaxies contain stars, planets, and gases. All the visible universe, the Earth, Sun, stars, and galaxies, everything that makes us, is made of protons, neutrons, and electrons bundled together into atoms. Physicists have developed an impressive body of knowledge about the fundamental particles and forces that characterize the ordinary matter around us. Centuries of discovery have shown that apples fall from trees for the same reason that the Earth orbits the Sun, and that the Earth is not at the center of the universe. It is a simple and elegant picture. The quest to answer the most basic questions about the universe has reached a singular moment. Astrophysical and cosmological observations have revealed that our picture of the universe is incomplete. Perhaps one of the most surprising discoveries of the 20th century was that ordinary matter makes up less than 5% of the mass of the universe. The rest of the universe appears to be made of a mysterious invisible substance named dark matter and a force that repels gravity known as dark energy. The exotic unknown substance named dark matter doesn't appear to absorb, reflect, or emit light, rendering it invisible. Since dark matter interacts very weakly with normal matter, its existence is inferred due to its gravitational effects on galaxies. Its fingerprints appear only when we look to the sky, high at the galactic and supergalactic scales, at about 10 million times the distance between the Earth and the Sun. The cosmic dawn continues with the James Webb Space Telescope as our guide. With each discovery, we move closer to unveiling the secrets of the early universe and gaining a deeper understanding of the forces that shaped the cosmos. The high-resolution images of galaxies observed by the James Webb serve as a time machine, allowing us to peer into the past and draw nearer to the enigmatic origins of our universe. The cosmos unfolds its mysteries, and we, as explorers of the unknown, stand at the precipice of discovery. In a piece of good news, scientists using a NASA space telescope have discovered a tantalizing world. It's about the size of Earth, sits remarkably close to our solar system, and could be comfortable for life as we know it. The extrasolar planet, or exoplanet, named GJ1214b, orbits a small and cool red dwarf star located just around 40 light-years from Earth in the constellation Pisces. The exoplanet, which the team found with NASA's Transiting Exoplanet Survey satellite, TESS, is estimated to have a width around 1.1 times that of Earth, making it similar to our planet as well as Venus, which is often called our world's solar system twin. GJ1214b orbits its star, GJ1214, so closely that its year lasts just 1.28 Earth days. However, because the red dwarf GJ1214 is just around a quarter of the size of the Sun, it is also much cooler. This means that even though GJ1214b is at a distance from its red dwarf parent equivalent to just 7% of the distance between the Sun and Earth, it still is in its planetary system's habitable zone, also known as the Goldilocks zone. The habitable zone is the region around a star that is neither too hot nor too cold for planets to host liquid water, a vital ingredient for life as we know it. Though importantly, the two teams behind the discovery of GJ1214b can't yet say for sure if it has an atmosphere. It therefore remains unclear if the world could be habitable. but the researchers have some cautious optimism. As University College of London scientist Lisa Palla, who co-led the research with University of Southern Queensland astrophysicist Shashir Dutta, said, "The majorly interesting thing is that this is a planet that's really nearby. In fact, it's one of the closest transiting planets to Earth. It's either in the habitable zone of its star or it is right on the edge of it, so it could be habitable." Scientists spotted GJ 1214b as it crossed or transited the face of its parent red dwarf star. These transits cause tiny dips in light that TESS is adept at spotting. Palla added that when the team went into this project, they didn't know what the orbital period or the size of the planet would be for sure. To find it to be such a similar size to Earth was kind of a lovely surprise, she continued. So that was a really nice thing to be able to nail down. But I think especially knowing that, in terms of habitability, it could lie between Earth and Venus is really exciting. GJ 1214b receives around 85% of the radiation that Venus gets from the Sun, but is thought to have a much cooler surface temperature of 107 F, 42 C, compared to Venus's surface temperature of 867 F, 464 C. Though Earth and Venus are both in the Sun's habitable zone, one can support life and has a favorable atmosphere, while the other is an inhospitable hellscape with temperatures hot enough to melt lead. Studying GJ 1214b could help us understand why this is the case. In the words of Palla, GJ 1214b could teach us a lot about how our own solar system has developed as well. The team will now investigate whether GJ 1214b has an atmosphere, but early indications are that if it does, that atmosphere would be relatively thin. Perhaps surprisingly, however, the lack of a thick atmosphere is good news for the planet's habitability prospects. As Palla fellow UCL researcher Vincent Vanis said, "We know some planets have very thick atmospheres of hydrogen that cover the entire planet. This very thick gas layer is actually bad news for habitability. Usually, these planets are 2 or 3 times the size of Earth. GJ 1214b is the actual size of Earth, so it probably doesn't have this very thick atmosphere. However, even if GJ 1214b does not have an atmosphere, it could still be an important test subject for advancing our search for life elsewhere in the Milky Way. That's because, as a red dwarf, the star it orbits happens to be the most common form of star in our galaxy, yet one we know relatively little about when it comes to red dwarf planetary systems in the Milky Way. Red dwarfs comprise the largest family of stars that are still fusing hydrogen to helium in their cores, a process that defines the so-called main sequence lifetime of a star. It is estimated that 60% to 70% of the stars in our galaxy are red dwarfs like GJ 1214, and of the 30 stars closest to Earth, at least 20 are red dwarfs. It's interesting to know about planets around the small stars, what they might be like, and whether such planets could have life, Vanis added. Officially known as M-type stars, red dwarfs have between 75% and 50% of the mass of the Sun. This low mass relative to the Sun means such stars burn at a lower temperature, reaching only 3,500 degrees Celsius compared to the 5,500 degrees Celsius temperature of our star. For instance, GJ 1214 has a surface temperature around 60% that of the Sun. This lower temperature means that dimly shining red dwarfs can exist as main sequence stars for much longer than moderately massive stars like the Sun can. And although the Sun is expected to live for around 10 billion years, red dwarfs are predicted to have lifetimes tens or even hundreds of times this period. Sometimes that figure can extend to trillions of years. What this means is life would have more time to develop on planets orbiting red dwarfs than it would on planets around larger main sequence stars. But it isn't all good news for the prospects of life on red dwarf orbiting exoplanets. Though they are cooler than the Sun in their stellar adulthood, red dwarfs are believed to be much wilder than our star. This class of star is believed to be highly magnetically active, blasting out frequent and powerful flares of high-energy light in the form of X-rays. These X-rays can violently strip the atmosphere of a planet close to a red dwarf. Additionally, recent research has suggested that even red dwarfs that remain placid for many years can suddenly erupt with superflares 100 to 1,000 times more powerful than the Sun's solar flares. These eruptions are more common in the youth of the stellar class and are also capable of stripping atmospheres and boiling away liquid water even in habitable zones.